All right, guys. So this video is we're going over how to predict products. So if just given reactants, figuring out what type of reaction might take place, and then figuring out what the chemical formulas are of our products, and then once we have what the products are, then we can go back and balance the equation. Okay. So this used to take a lot of memorization. You used to have to memorize all these things. Now you don't have to memorize them. You got to just know how to use these different resources. So whenever you're tasked to predict products, you will always have you're predicting the product scenarios, which you're going to have individual copies of from class, but also it's one of your appendices in your visible learning document. I think it's Appendix D, but you can check that. You also have your solubility rules, which again you used to have to memorize, and now you just need to know what they mean and how to use them as a reference, and something called the activity series. So you will get all three of those things on a test or quiz where you have to predict the products. You just have to know how to use them. And until you get a good idea of how to predict the products, you also might want to have your predicting the products cheat sheet out to help you, but you don't get that on the test. You get everything else, but you don't get the cheat sheet. But the cheat sheet you might want to have out while you're working through your practice problems on the Schoology assessment. Okay, so again, this is 6-4 in your visible learning, predicting the products. But again, before you start predicting products, make sure you have your solubility rules out, make sure you have your activity series out, and make sure you have your scenarios out, because the scenarios will a lot of times tell you exactly what you get, what products get produced. So let's jump into it. All right. So again, make sure you have your scenarios sheet. All right. Make sure you have your solubility rules. Okay. And make sure you have your activity series. Okay. And we're going to get into when you need to use the activity series, when you need to use the solubility rules, and just when you might just need to use the scenarios. Okay. But again, the other thing you might want to have out is you're predicting the product's cheat sheet, because this, whoops, I don't want to mess that up. This right here, this will tell you kind of what type of reaction you might be expecting. And then once you understand what type of reaction you might be expecting, you'll go to your scenarios. If you think it's a synthesis reaction, it's one of these scenarios. If you think it's decomposition, it's one of these. If you think it's single replacement, it's one of these. Double replacement, combustion. And then there's a couple times where you might get a no reaction occurs, and we'll talk about that scenario. Okay. All right. So when you're tasked to predict the products, understand. Whoops. Let me go back to here and okay. You have to decide first off based on the reactants that I have, what type of reaction will occur. Okay. And then once you narrow it down to, synthesis, decomposition, single replacement, double replacement, or combustion, then you can go to your scenarios sheet and figure out which particular type of decomposition reaction is going to take place, or what particular type of single replacement reaction is going to take place. All right. And then once you know what type of reaction is going to take place, you have to figure out what your products are going to be. So get the correct formulas for your products. And then at the end, you just balance the reaction. Okay. So let's go through an example here. So here, oops, that might be a little too much. All right. So here I got sodium and chlorine yield something. I got to predict the product. I got to figure out what that is. So what we're doing is figure out what you have. You have two elements. Anytime you just have two elements, you should be thinking synthesis, right? So it's a synthesis reaction. If this is going to occur, two elements, they're going to combine and make one thing. It can't be a replacement, because you have to have at least one compound in a single replacement reaction. You have to have two compounds in a double replacement reaction. You have to be burning in oxygen for it to be combustion, right? And you can only have, if you have one thing on this side, then you're thinking decomposition. So two elements, you should be thinking synthesis. All right. So we'll go to our scenarios. Whoops. and we'll see what types of things we have. So these are the different synthesis reactions. But notice scenario A, metal and non-metal produce ionic compound. Well, that's what we have. If we go back to our example, we have a metal and non-metal. Sodium's a metal, chlorine's a non-metal. So we're going to get an ionic compound between sodium and chlorine. So what do you think that is? Sodium chloride, okay? So NaCl, or sorry, sodium plus chlorine yields NaCl. Now, this is where students mess up, okay? They know that they're going to get sodium chloride. And guys, before you even come into chemistry, you guys know the formula for sodium chloride, right? This is not a complicated one. This isn't a new one you learned how to do in Unit 4. This is a compound you already know the formula. Just like water you know is H2O, right? But a lot of students will put a subscript 2 here because chlorine has a subscript 2 over here. This is the element chlorine, which is diatomic. This is the ion chloride, which there could be 2 chlorides, it could be 3 chlorides, it could be 4 chlorides. That's dependent on whatever the charge of this ion is. Well, you know sodium's +1 and you know chloride's 1-, it's a 1-to-1 ratio. So this is the correct formula of the product, sodium chloride, and then to balance it, that would be the balanced equation. So again, just understand how it worked. Based on the 2 reactants given, choose synthesis. Go to your scenario sheet and figure out which synthesis reaction makes the most sense. Which of these scenarios makes the most sense? In this case, it was scenario A, okay? And now we have to get the right formula for sodium chloride, and now we come back and we balance our equation, all right? So let's check this one out, all right? So here I got ammonium hydroxide yields question mark, right? So I got to figure out what the product's going to be. All right, well, ammonium hydroxide is a single compound. I only have one thing on this side, so it's got to be decomposition. So it's got to be decomposition. It's got to be a decomposition scenario. So let's go to our scenarios and let's find the decomposition that makes the most sense. All right, so if we look at scenario G, it tells us exactly what we're going to get. And it tells us ammonium hydroxide decomposes to form water and NH3. Well, our one reactant was ammonium hydroxide. So scenario G must be happening, and it tells us the products are water and ammonia. So that's the easiest one. Boom, it told me. So here's my reaction, okay? And it's balanced, all right? Now, 1 nitrogen, 1, 2, 3, 4, plus 5, 1. So we got 5 hydrogens, 1, 2, 3, 4, 5. We got 5 hydrogens, 1 oxygen, 1 oxygen. It's balanced. That's our equation, scenario G, okay? Now we're going to skip to combustion first because there's one more little thing we have to make sure we watch out for when we're talking single replacement or double replacement. But combustion, those are going to be the easiest ones to predict and the easiest ones to predict the products, right? Because if it's combustion, we're just going to get CO2 and H2O, right? So here we have a hydrocarbon plus oxygen. Anytime we have a hydrocarbon and oxygen, we should be thinking combustion. But let's look at our scenarios. So for combustion, we're only given 2 scenarios. We either get combustion of a hydrocarbon, which is going to be this scenario. So we got scenario R going. But then we also have combustion of an alcohol. Well, if we go back here, C4H8 is not an alcohol. It's just a hydrocarbon. So what would this be? This would be butene. This is the combustion of butene. And so that's our reaction. It's not balanced, but those are our products. I know I'm going to get CO2 and H2O. And then to balance it, we can follow our steps for balancing a combustion reaction. Okay, so there's our balanced equation. Okay, so here we have an alcohol in oxygen. So again, if oxygen is one of our reactants, we should be thinking maybe combustion. And you know it's absolutely combustion if it's an organic compound and oxygen, right? So it's combustion. But this would be combustion of an alcohol, not combustion of a hydrocarbon. So this is scenario S. Again, if we go back and look at it, R is combustion of a hydrocarbon, S is combustion of an alcohol. All right. But again, regardless of it's a hydrocarbon or an alcohol, our products are CO2 and H2O. Now just, we have to balance. So balancing this one's a little bit more difficult, but I'm sure you could take the time and figure it out. And here's our balanced equation. All right. So what about single replacement and double replacement? If you think you're going to have a single replacement reaction or a double replacement reaction, you have to go one more step, because there's a possibility that no reaction is going to occur, right? There's a possibility that no reaction occurs. So if we look at our predicting the product scenarios, notice down here we have two places where we might have a no reaction. Okay, notice scenario T tells us no reaction due to activity series, and scenario U says no reaction due to the fact that both products are soluble based on solubility rules. So let's understand, scenario T, the activity series, is only for single replacement, okay? And scenario U is only for double replacement, essentially, okay? So anytime you're thinking single replacement, it could be one of these, but then the other possibility is no reaction, scenario T. If you have a double replacement, it's either this one, or it could be scenario U. Okay, so for double replacement, it could be scenario U, no reaction, and for single replacement, it could be scenario T, no reaction. Okay, but the activity series is only for single replacement. Solubility rules is usually for double replacement if you're trying to figure out if you get a precipitate or not. Okay, all right. So let's dive into it. All right. So again, scenario T would be no reaction if you were expecting single replacement, and scenario U would be no reaction if you were expecting double replacement. All right. So let's look at this one. We got sodium plus magnesium nitrate. So we're trying to predict the products. So look at what you got. You got an element in a compound. If you have an element in a compound, you should be thinking single replacement, okay? Unless this was oxygen and a hydrocarbon, and then we'd go back and it'd be combustion, right? But we have a metal and we have an ionic compound. We should be thinking single replacement, okay? So let's go to our predicting the product scenario. So let's look at the types of single replacement reactions we have. So this one would be the first single replacement on the list, scenario K. Metal replaces metal. So if we go back to our scenario, it'd be sodium replaces magnesium, right? But the other thing it could be is scenario T, okay? So here's the big thing. Whenever you're thinking single replacement, you have to ask yourself, can this replace that? So yeah, if anything's going to replace anything, the metal's going to replace the metal. So sodium's going to replace magnesium. But you have to ask yourself, can sodium replace magnesium? If yes, then you'll get the reaction. If no, you'll get scenario T, no reaction. So what do you check? You check your activity series. So let's go to our activity series and let's look at it. Sodium is here, magnesium is here. So if whatever's doing the replacing is above what it's going to replace, it can replace. Sodium can replace magnesium. If it was the other way around and magnesium was trying to replace sodium, magnesium is lower than sodium on the activity series, so magnesium can't replace sodium, but sodium can replace magnesium. So again, let's think about what we did. We saw that it was sodium. If a single replacement reaction is going to happen, it was going to be sodium replaces magnesium. Then you had to ask yourself, can sodium replace magnesium? And the answer is yes, because sodium is above magnesium on the activity series. So it can. So the answer is yes. So we will get scenario K. We will get a reaction. We won't get scenario T. We won't get a no reaction. Okay? So what are we going to get? We're going to get sodium paired up with nitrate. That's sodium nitrate. And we're going to get magnesium, the element. Now, notice this isn't Mg2+, it's just Mg. Okay? And notice, yeah, nitrate had a subscript 2 here, but when it's paired up with sodium, it only has a subscript of 1. And so to balance it, we got to adjust our coefficients to balance the equation. Okay? But that's, if it's single replacement, you got to go one step further, consult your activity series. Okay? So let's go to the next one. So here we got bromine, the element, and sodium chloride, the compound, element compound. So we're thinking a single replacement. Let's go to our scenarios. If we go to our scenarios, we're thinking it's scenario N, halogen replaces a halogen, right? Bromine replacing chlorine in this case. Or, again, it could be scenario T, no reaction due to the activity series. So it's one or the other, okay? So it's either halogen replaces halogen or scenario T. But the question is, can bromine replace chlorine, right? Can bromine replace chlorine? And so we go to activity series. Now, for the halogens, it's just the order and they appear on the periodic table. So chlorine is above bromine. Bromine is below chlorine. So bromine cannot replace chlorine. So the answer is no, bromine can't replace chlorine. Chlorine's more reactive. It's higher up on the activity series. So the answer is no, therefore no reaction, right? So all you would have to do, like here, is write no RXN, no reaction. This is scenario T. No reaction because bromine can't replace chlorine. If it was the other way around, if we had chlorine and sodium bromide, yeah, the reaction would take place because chlorine can replace bromine, but bromine cannot replace chlorine. Okay? So that's scenario T. All right? So what about the double replacement reactions? So really, it's just when I mix two ionic compounds that are dissolved in water, if I mix two aqueous solutions of ionic compounds, the question is, do I produce a compound that's not soluble? So it undissolves out of water. It does what we call precipitates out of water. Soluble salts will stay dissolved. Insoluble salts will precipitate, will undissolve. It would be like I'm mixing salt water into salt water and all of a sudden solid salt forms out of solution. It falls out of solution. It precipitates out of solution, undissolves. And that's why you're going to check your solubility rules. So let's look at your solubility rules real quick. So this is telling you what's soluble and what's insoluble. This is telling you what's insoluble versus soluble. Remember, soluble means stays dissolved, stays aqueous. Insoluble means precipitates out of solution, forms a precipitate, okay? So if we look at our scenarios, we're either going to get double replacement formation of a precipitate. If one of our compounds produced is insoluble, it'll form a precipitate. Or it'll be no reaction because both ionic compounds that could be produced from the reaction are soluble. So they stay dissolved and nothing changes, okay? So it's either going to be scenario P or scenario U when we're talking double replacement, okay? So let's go to our example. All right, so here we have barium nitrate and sodium sulfate. But notice, look at it, it's aqueous and aqueous. What does that mean? It means this salt dissolved in water, this salt dissolved in water. So really what we have is barium ions and nitrate ions surrounded by water floating around. We got sodium ions and sulfate ions dissolved in water floating around. And what we're going to do is mix the two solutions together. So what it's going to look like on kind of a macroscopic level is water mixing with water, right? It's going to not look like anything's happening unless we make something that's insoluble. So we have two ionic compounds. We should be thinking double replacement. If we looked at our scenarios, it's either double replacement formation of a precipitate, that's scenario P, or no reaction because nothing precipitates out of solution, okay? So we got to figure out what the two products are going to be. So barium paired up with sulfate, so we're going to get barium sulfate, and sodium paired up with nitrate. We got to get the right chemical formulas for that, right? So barium's a 2+ ion, sulfate's a 2- ion, so that's a 1-to-1 ratio. So this is the correct formula for barium sulfate. Sodium's +1, nitrate's +1, so that's the correct formula for sodium nitrate. So these are our two compounds that could be produced, but we got to check, is one of these going to precipitate? Is one of these considered insoluble based on solubility rules? If yes, then it will form a solid and precipitate out and we'll get a reaction. Okay, scenario P. But if both of these are soluble, then this will stay dissolved and that will stay dissolved and there won't be a reaction. So let's check. Let's check on sodium nitrate. Is that soluble or insoluble? Let's go to our solubility rules. Wrong thing, solubility rules. So notice it says alkali metal compounds are always soluble. So sodium, always soluble. And notice it says nitrates, always soluble. So what does that tell us about sodium nitrate? This is soluble. This is going to stay aqueous. This is going to stay dissolved. Okay? But what about barium sulfate? Let's go to our solubility rules. All right, notice it says compounds with sulfate are most of the time soluble, but there's exceptions. And notice the first exception, barium paired up with sulfate. Barium sulfate is insoluble. That means it's going to precipitate. So we will get a reaction here. This will be scenario P. Barium sulfates are precipitate. So if we go to our balanced equation, right, I got to put a 2 here to balance everything. But the states of matter are really what kind of matter in this scenario, right? Aqueous salt yields solid salt and aqueous salt. So what this is telling us is the sodium and the nitrate are staying dissolved. But when the barium and the sulfate bump into each other, they precipitate out. They form a solid. So what would this look like? This would look like water. This would look like water. We mix the two, and all of a sudden, we get a bunch of solid particles forming in our solution, and they would slowly fall to the bottom, right? And that's what a precipitate is, okay? So let's look at this one. So we got potassium chloride and sodium nitrate. So we're thinking double replacement reaction. We'd end up with potassium paired up with nitrate and sodium paired up with chloride. Everything's a +1, -1 charge here, so everything's going to be a 1-to-1 ratio. Everything's going to be balanced with a coefficient of 1. But the question is that soluble or insoluble? Or is that soluble or insoluble? Or if they're both soluble, then it's going to be scenario U, and we don't get a precipitate, okay? So if we check our solubility rules, remember, just solubility number 1, alkali metal compounds are soluble. So here's an alkali metal compound, soluble. Here's an alkali metal compound, soluble. So both of these compounds are soluble. You're not going to get a precipitate. No precipitate, nothing happens. What it would look like is this looks like a water. This just looks like water. Potassium chloride looks like water. Potassium chloride solution looks like water. Sodium nitrate in solution looks like water. And then when we mix the two, since none of these things undissolve, since none of these things over here precipitate, it's just going to look like we poured water into water and nothing really happened. All right, so it's a no reaction. This is scenario U, okay? And so to get a better understanding of precipitation and what's going on in your beaker when you're mixing compounds and solubility rules, you might want to watch the videos in the 6-4 folder, what's in the beaker and net ionic equation practice. You don't have to, but it might help you get a better understanding of what we're talking about here. But the main thing is just, practice predicting the products, okay? So hopefully that helps. And again, it just takes practice. So you got your scenarios, you got your solubility rules, you got your activity series, you just got to know how to use them. And then you got to trust your rules from Unit 4. You know how to write the formulas of these compounds. Don't let the fact that the subscript of this is X on this side of the equation and make it have to have the same exact subscript on that side of the equation. Remember, get the right formulas based on what the compounds are, okay? And then you adjust the balancing of the reaction by changing the coefficients, not the subscripts, all right? So anyway, hope that helps. Have a good one.